Welcome to Algebra Quiz 2. In this quiz, which is listed in my blog, vijayrahavendran.wordpress.com, the quiz is this. There is a number which consists of 3 digits whose sum is 9. When the number is reversed, the number is decreased by 198. The sum of the original number and the number formed by reversing the digits is 666. Sorry, 666. So find the number. Okay, we've got a 3-digit number whose sum is 9, and when you reverse the number, add the original number, you should get 666. And the difference between the original number and the reversed number is 198. Okay, so that's the problem, and let's go about doing this. Okay, I've already done this, but let me take you through the different steps. So I did the hard way. Okay, I assumed that the 3-digit number is this. You've got A, B, C. You've got the units, tens, and the hundreds place the different digits. So the first thing is this one, which is the sum of the number is 9. So I did that one. A plus B plus C is equal to 9. And then the second one is the difference between the numbers is 198. So I made an equation where 100A plus 10B plus C, which is the original number, should be equal to the reversed number, which is this one here, which is 100C, because the reverse number is going to be CBA. So it's going to be 100th position, there is C, so 100C plus 10B plus A, and then you add 198 to it to get the original number. The third one is you add both the numbers, the original number and the reverse number, you get 666. Okay, I've got 3 linear equations in A, B, C, and we know how to solve it. Okay, so from the second equation here, I simplify the whole thing there, and I get 99A minus 99C is equal to 198. So divide by 99, and I say A minus C is 2. Okay, that's the fourth equation we've got. And then from the third equation here, where the sum of the numbers, the reversed one and the original one is 666, you simplify that and you get this one. So I've listed them here on the right hand side as 3 linear equations, and we can go about doing it in different ways, by substitution, by elimination, by making it in terms of 2 variables and then solving it later on. So I did it by inspection. So what I do is, so I've got the third one, which has got 101A and then 101C. And then I look at the first one, the A and C, they have unit coefficients. So I'm simply going to multiply the first equation here by 1 and then subtract it from the fifth one. Okay, that's what I've done it below, which is this. So multiplying the first equation by 101 and then subtracting it from the fifth equation, you get 81b is equal to 243 with minus on both sides, from which we get b is equal to 3. Also, we get from 4, a minus c is equal to 2. So I get a is equal to c plus 2. Substituting this in 1 again, in the equation 1, I get c is equal to 2. So when a plus b plus c is equal to 9, a has to be 4. So the number is 432, which is the reverse number 234, to which you add 198. And then when you add the original number and the reverse number, you get 666. So this is a very long way of going about doing the problem. We have used all the 3 equations, and we've known how to do algebraic equations, solving them simultaneously, and we get the answer. Okay, so that's the first one. So the second one, which was done by my tutee, to whom I gave this quiz every week at the beginning of the week. So he did it in a very different way, and he employed only 2 equations. He completely ignored the first one, which is the sum of all the numbers is 9. So what he did was very clever. So he did the original number, which is ABC, and to which I add the reverse number, I get 666, and then the original number should be equal to the reverse number plus 198. So he's got two linear equations, but in ABC form. So he simply subtracted the second one from the first one, rearranged the equation, and he got twice CBA is 468, from which he says CBA is 234, and then CBA and ABC are related by the first equation, and he gets ABC is equal to 432. Pretty clever. Okay, and then in the third method, which I'm going to use the linear equations, all three of them, but instead of solving it manually, I'm going to use Excel, Microsoft Excel 2010 to do this problem. And I would recommend very much this book here, which is Engineering with Excel by Ronald W. Larson. It's a fantastic book, and I'm sure he's got some videos on YouTube, and he talks about matrices and determinants and inverses of matrices. And on his website, he's got, when you search Ronald Larson on Google, it will take you to his website for the book, and you can download the datasets are mentioned in his book. Okay, so the Excel method is this. So I've written it in this fashion here. Okay, I've listed the coefficients and the variable x. So the coefficients are 1, 1, 1 for the first equations, because 1 times a plus 1 times b plus 1 times c should be equal to 9. So this is the matrix way of writing an equation. So the second one is 101 times a plus 20b plus 1c should be equal to 666. And then the last one, which I have simplified, is 1 times a, 0 times b minus c should be equal to 2. Okay, I've named this. So what I do is I highlight this whole thing, and in this name bar here, the name box, I list this as coefficient, and I'll list the ABC vector as x. So to do that, simply highlight this and put in x and enter. That's it. And I call the right hand side as this thing, this vector, which is 9, 666, and 2. So what the matrix equation says is we've got a coefficient times x is equal to the RxH right hand side. So to get the x vector, we simply have to take the inverse of this coefficient and then multiply it by the RHS. Okay, so that's what I've done now, which is I've taken the inverse of this one. So to take the inverse of this matrix, the coefficient matrix, what you do is you have to highlight 3 by 3 rows and columns, and then write equal to, and then M inverse, that's the formula, Excel formula to write the inverse of a function, of the array, I mean. So the array is, which is listed above, coefficient. And then you can't simply do enter, but you have to do Control Shift and enter. When you do Control Shift enter, Excel puts this curly brackets. So the curly brackets means that it's the array entered formula. So now we've got this particular bit, which is the coefficient inverse. And then we have to multiply the coefficient inverse by the right hand side. So what I've done this in this one here, I'm just showing that when you multiply the original coefficient matrix with the inverse of the coefficient, you get a null matrix. This is a null matrix, which is 1 0 0 0 1 0 0 0 1. That's what I've shown. This is a property. And then to find out x, I multiply the coefficient by the RHS, which I've done it here. It's going to be a 3 by 1 matrix. I used again matrix multiplication, coefficient inverse times RHS. Control Shift entered. Excel puts the curly brackets, and you get the coefficients, which is A is equal to 4, B is equal to 3, and C is equal to 2. So that's the third method of doing it. And then the last one is, of course, our Wolfram. Wolfram, you list the equations like that, A minus C is equal to 2, and then the third one, that's the input, and it gives you alternate forms, and boom, it gives you the solution. So if you want a quicker way, Wolfram, if you want to know the steps, the manual algebraic way, if you've got 10 sets of linear equations, the Excel method would be the best.